So I have been assigned to do a requirement for a math class today, which is simply to make a video about arithmetic sequences, another math lesson that will most likely be something that I won't use later on in my life. But since it is graded and that the teacher is making it look like my whole entire life depends on this, I'm making a video about it. Just to give you a brief introduction of what arithmetic sequences are, an arithmetic progression, or sequence, is a sequence of numbers such that the difference between each consecutive terms are constant. For example, the sequence 2, 4, 6, and 8 is an arithmetic sequence because the common difference between each term is 2. It seems like a very easy math lesson to have for a grade 10 student, but when you want to find a random numbers term, hence the nth term, you start to see where the complicated part of this lesson comes into play. For example, here's a sequence, alright? Now tell me, what's the nth term of the sequence? You can just say, oh, just add 3. But this is math, and you would have to translate your words into a formula. Luckily, there's a universal formula for solving for any nth term of the sequence, which is given by this equation over here, wherein n is the nth term that you're trying to find, a1 is the first term of the sequence, and d is the common difference. I have to say that this math lesson can be pretty useful, which leads me to the next part of this video. You see, I have been assigned to make a real-life problem in which only arithmetic sequences can solve. Well, other than the fact that making this video is a huge problem already and can only be solved with arithmetic sequences, I made my own word problem with this useful lesson. I could have researched for it, but I noticed that it should be something useful. So after twisting my pencils and thinking of what I should be doing instead of this, I finally made a real-life problem, both mathematically and literally. So here's my question. There's this one person that I would call Matthew, right? In the first day of the month, he ran 21 kilometers. But then he had a severe cramp and he wanted to go easy in his training. So he runs 3K every morning so that he doesn't get too overworked. However, his monthly goal is to have run an overall distance of 51 kilometers for the whole month. In what day of the month would Matthew have achieved this goal? To answer this, let's try to get the first 4 terms of the sequence. We now know that Matthew had run 21 kilometers in the first day, so that's the first term of our sequence. With the information we gathered, we know that Matthew runs 3K every day. This bit over here is the common difference in our sequence. Since we have our common difference, we can now see that the next term would be 24, and then 27, and then 30. It could have been easy to keep counting until we reached 51 kilometers, but we need a faster way to reach 51 kilometers. To do that, all we need is to follow this equation right here. If you can't remember what I just said a few minutes ago, this is the equation we used in solving the nth term. But we are not looking for what the nth term is. We are looking for what n in the word nth term is. To do that, we replace the sum of the equation with 51, since that this is what the nth term is. Replaced a1 with the first term of our sequence, 21, and replace d with 3. After doing so, you're left with the formula to solve. You transfer 21 to the left side, divide both sides by 3, and you transfer -1 to the left side. After doing all that, you're left with 11. Wow, it seems like math will have to look for a new goal after that. So in conclusion, this is my arithmetic sequence problem. Can't believe I made a problem like that myself. But in all seriousness, I do have a question to point out. I found a video that sort of uses the equation y equals mx plus b to solve an arithmetic sequence problem. And I have to say that this equation works perfectly fine. So please explain to the class something about this equation, because this is actually a lot easier to understand than an equation like this. I might be wrong, but tell us something about this equation, or we will just be left dumbfounded with what this is doing here in the first place, alright? Okay.